Good day, everyone. This report discusses the fire and explosion risk associated with fine powders and their significance in engineering operations. Let's start off with the table of contents. First, introduction. Second, the combustion of fundamentals. Third is the combustion in dust clouds. And lastly is the control of the hazard. Fine powders, also known as combustible dusts, can ignite or even explode when dispersed in air under the right conditions. These risks arise because fine particles have a large surface area relative to their volume, allowing them to react rapidly with oxygen. Dust explosions have caused serious property damage and loss of life across various industries such as food processing, metal fabrication, and chemical manufacturing. Understanding these risks is essential for engineers to ensure safe plant design, hazard prevention, and worker protection. The hazards presented by fine powders can be classified into two main risks. Fire, when fine powders can easily ignite because of their large surface area, which allows rapid oxidation when exposed to air. Even a small spark, hot surface, or static discharge can start a fire once the dust is heated above its ignition temperature. Explosion, when combustible dust becomes suspended in air at the right concentration. It can form a flammable cloud. If ignited, the burning particles release heat and pressure rapidly, leading to a dust explosion that can cause severe damage and secondary blasts. Fine powders are commonly handled in many industrial sectors, including food processing such as flour, sugar, and grain handling, metal processing involving aluminum or magnesium powders, plastics and pharmaceutical industries, and energy and chemical plants handling coal or biomass. These processes often involve grinding, drying, conveying, and packaging, which can generate dust clouds and increase explosion potential. Common ignition sources and equipment include storage silos, dryers, and dust collection systems, conveyor belts, bucket elevators, and mills, and hot surfaces, friction, or electrostatic discharges from machinery. If not properly controlled, these systems can easily create conditions that can lead to ignition and combustion. A well-documented example is the Imperial Sugar Company explosion in Port Wentworth, Georgia, USA in 2008. In this incident, fine sugar dust accumulated on floors, equipment, and overhead surfaces. When the dust inside an enclosed conveyor came into contact with an overheated bearing, it ignited and caused a primary explosion. This initial blast disturbed more settled dust throughout the facility, leading to massive secondary explosions that destroyed much of the plant. The disaster resulted in 14 deaths and 38 injuries. Investigations revealed several key issues: poor housekeeping that allowed dust buildup, inadequate ventilation and dust collection systems, poor maintenance of machinery, and lack of worker training and hazard awareness. This tragedy highlighted how small ignition events can rapidly escalate when fine powders accumulate and engineering controls fail. From an engineering perspective, understanding and managing dust explosion hazards is critical for process safety. Engineers must design safe systems, including proper dust collection, ventilation, and explosion venting. Implement preventive maintenance, ensuring equipment remains clean, grounded, and free from ignition sources. And provide training so that all personnel understand proper handling, cleaning, and emergency procedures. Following safety standards, such as those from the Philippine Integrated Fire Protection Organization, helps ensure facilities remain compliant and secure. By combining good design, maintenance, and safety culture, engineers can effectively prevent dust related fires and explosions, protecting both people and industrial operations.